welcome to Thursday's edition of Cracking the Cryptic, and the puzzle on the screen reminds me of the Miracle Sudoku. There's just a 1 and a 2 in the grid, and this arrangement of thermometers. There are no special rules to this puzzle, which is called Geometry Exam number 2. And it's by Blashyrkh, and I did a Blashyrkh puzzle very recently on the channel. It was magnificent, but this one has been recommended about 4 times in the last 24 hours, and some of the recommendations are eulogizing about this. People are saying it is insanely brilliant, and I found it on Logic Masters Germany before I turned on the webcam, and I love the sort of preamble that Blashyrkh has used. It reminds me of Fermat's last theorem. It says something like, if you spot the geometrical trick involved in this puzzle, all of the digits can magically be placed almost immediately. It's like in the margin. I can't quite fit into the margin. The incredible proof I've discovered that x to the n plus y to the n equals z to the n has no solutions for n is greater than 2. Good luck finding out what it is. We're going to find out today whether we're Andrew Wiles or whether we are, I don't know, merely Simons and Marks. This is what we're going to test. Anyway, the other thing about this puzzle, it only has 2 stars out of 5 for difficulty. So in theory, we all should be having a go and getting through it with no problem. I'll read you the rules, which will take me about 1 second in a moment or two. But before I do that, I want to say a very happy birthday to Scott. Your wife Shiloh wrote to us, Scott, and said that you watch Sudoku like it's a sport. Well, of course you do. It is a sport. That is what I think. That's what Cracking the Cryptic has sort of proved. Watching Sudoku is a bit like a sport, and people shout at us and they get emotionally involved, and that is, that's almost what sport is, isn't it? So, Scott, happy birthday today. I hope you have an absolutely brilliant one, of course, with chocolate cake. But the other shout out I've got to do is not for a birthday; it's for a graduation. Isaiah, you are getting your associate's degree. It's either today or tomorrow, I'm not sure, but your Uncle Edwin wrote to us, describing himself as the Tucson Quack. And your Uncle Edwin is flying into Washington from Arizona to attend his first college graduation and see you get your degree, Isaiah. So clearly a very, very proud uncle, and sincere congratulations from us both here on your achievement. That is fantastic news, and I hope there will be cake involved in the celebration. Now, the only other thing to mention is over on Patreon, we've got the Planet Suite. We keep getting more and more entries. We keep getting more and more facts. Today's fact, actually, have I got a picture of the Planet Suite? So it's our Sudoku hunt. It's well worth doing. You can still, if you become a patron now, you've still got 5 days to enter the competition, and that's more than enough to solve it. It'll only take you 2 or 3 hours, I would think. Anyway, the fact today comes from Stephen Lee, who tells us that Mars has the biggest volcano in the solar system on its surface, and apparently that volcano is called Olympus Mons, and it is 3 times taller than Mount Everest. Now, that is incredibly large. That is incredibly large. I always think of Everest as like, if you're in a jet plane and you're at cruising altitude, that's not far off the height of Mount Everest. So think about that, and think about a volcano that's 3 times that height. Yeah, that's daunting. Goodness knows what it's like when it erupts. But anyway, thank you for that, Stephen. Very nice fact, and keep the facts coming. Now we're going to have a go at Geometry Exam. I'm recording this quite late for me today. I had to go to the passport office earlier to renew my passport. It's a blistering hot day here in the UK, so that was not much fun. But this is going to be the best part of my day, whether or not I can solve it. Blashyrkh, I'm hoping you've constructed a solvable puzzle, but these are the rules. Normal Sudoku rules apply, so that means we've got to put the digits 1 to 9 once each in every row, in every column, and in every 3x3 box. And digits along a thermometer increase from the bulb end. So if this square here is a 1, this square has to be higher than 1, 3. It doesn't have to be 2. You can miss out digits. So something like that would be a completely legitimate way to fill this thermometer. The digits, as mercury would rise as the temperature rises, which it appears to have done in the UK, so must our digits rise as we move away from the thermometer bulb. Do have a go at the puzzle. The way to play is to click the link under the video as usual, but now I get to play. Let's get cracking. Now, I know exactly what a pencil mark would do at this point, and that would be to fill these thermometers, which are, well, the longest of them are 5 cells long, with a lot of pencil marks, because 1, 2, well, this can obviously be 5, 6, 7, 8 or 9, so each of these cells along this thermometer has 5 different options ab initio, and these have even more. Now what I tend to prefer to do, and I can do something here, I can see straight away, is I prefer to look at look at the geometry and think about it a bit holistically. So I can see something actually about ones in these columns, which I think is where I'm going to start. So if we ask the question, where can 1 go in these 3 columns, you get an interesting answer because of the given one in the corner. You can't put 1s there, and the only place along a thermometer you could ever put a 1 is in the bulb, because if we try and put 1 halfway up a thermometer, we have trouble. We have to go downwards towards the bulb, and 0 is not a valid Sudoku digit. So actually, you can see in these 3 columns, the 1 is in one of 3 places each time. And that is a very well, that is interesting. It's a sort of swordfish, but I don't think we need to go that far, do we? We can simply note that now it's impossible to put 1 in any of the bulbs of the thermos. So if Mark does start this puzzle, I will ask him actually if he has a go at this, how he starts it, because if he started it his way, he would have had to write 1 into this, 2 into this, 3 into this, 4 into this, 5 into this. But now if I was pencil marking it, because I know that these 2 cells can't be 1s in any of these boxes, I could do this. I'm not going to do this. I'm not. I'm just going to show you what it might look like were I to take advantage of pencil marking. Okay, so what we probably need to do is that again. We've got, you see, we have almost got something here. Because the fact that this is at least 2 means that these thermometer tips are now from this collection of digits. So we're getting to the point where we've very nearly got a triple here. If we can prove 2 doesn't go in any of the bulbs, well, especially these bulbs, then we've got a 7, 8, 9 triple in row 9. Now, okay, so it's going to be something to do with this 2, I think. Let me mull this over for a moment or 2 or 3. It's really close, actually. It is really close. I'm not going to use this. I'm going to look again at these columns, because where does 2 go in these columns? Remembering, you can't now put 2 in cells like that, because that's going to put 1 in the bulb where we know it can't go. So actually, none of the thermo cells in column 1 can contain a 2. So the 2s are in these positions now, in these 3 columns. So all I've got to do, if I can rule a 2 out of row 1, then we're in business. So if there is a reason in this puzzle why you can't put 2 into row 1 in the green cells, then 2 would be in this arrangement. 2 could not be in the bulbs of these thermos, and therefore these would be at least 3, which would make these at least 7, and these would be a 7, 8, 9 triple. And in fact, you'd then get stepping thermometers. Everything might then resolve in the way that Blashyrkh teased. Now why? Why is it you can't put a 2 into any of these 3 cells at the top? That at first blush is not at all obvious, is it? I'm sure this is it. I'm sure this is it. I'm just going to have to spot it. Why is it that these can't be 2s? Is it? Oh, the only other thought. Why have we got these thermometers as well? Because everything I'm thinking is about the bottom thermometers. Why are we given the? What are these thermometers? What is their purpose in? I can see. I suppose the purpose is to knock 2s out of those 2 squares. Maybe that is the most efficient way of doing that. Yeah. Okay. So. So what is it then? I don't know, actually. I'm so sorry. If this is obvious, I apologise. I have a horrible feeling it is obvious, because this puzzle is not, it's not rated in a particularly mean way, is it? I mean, it looks to me, at first blush, like all of those cells can be 2. This can't be 2 because that would put 1 in the bulb where we know it can't go. So 2 is sort of in a P pentomino in box 5, and a P pentomino and a P pentomino. No, okay. I might be on the wrong track then. Or maybe we've got to approach this question a different way. 2, 3. Yeah, okay. Alright, I'm just going to get rid of green for a second, because let's look instead at those cells, perhaps. Because those cells have an interesting property. They've all got to be different numbers, and there are 8 of them. And the reason I say they've all got to be different is obviously these 2 can't repeat in there because this is all on the same thermometer, so these must be lower than these digits. And these 3 cells see the entirety of the thermometer. For example, this cell sees those 2 in its box and these in its column. So this is 8 different digits. And that means, well, we don't know that there's a 9 in this. If we knew that, no, that's not even true. What I was about to say is not even true. Okay, I'm going to change my mind again. I'm sorry about this. I haven't quite got this yet. Okay, I'm going to highlight all of those cells now, because that's also interesting, isn't it? Because that's 11 digits. So they've got to be repeated digits in this number of digits, and yet that's quite difficult. Because obviously, you know, if this does repeat, well, yes, okay, let's deal with the obvious, I suppose, geometric implications. Those 8 cells must all be different. They're all in the same column. So there are only 9 different Sudoku digits. So it's possible that one of these is the 9th digit, but that would mean there must be at least 2 repeated digits in those three squares. So at least 2 of these, possibly 3 of them. Not 3 of them. Not 3 of them. It's not possible for all 3 of those to repeat, actually. Ah. Got it. I've got it, I think. Well, I've certainly got something. I've certainly got something. Right. Okay, so what gave it to me was thinking about how many repeated digits were actually possible. How are we going to show this? Don't know. Let's maybe use the letters. Right. Okay, I'm going to label these A, B, C. Okay, so let's set ourselves the task of repeating A, B and C within orange. I.e., can there be 3 repeats? Well, A can't repeat on its own thermometer, so A would have to be down there somewhere. B can't repeat on its own thermometer, so B would have to be up there somewhere, and C can't repeat on its own thermometer, so it would have to be up there somewhere. But now look at this. We've created a paradox here. That not even the margin of our page will accommodate. Because here, what we seem to be saying, if we just focus on A and C for a moment, C is a bigger digit than A on this thermometer. Yet on this thermometer, C is a smaller digit than A. So that cannot be right. So this is actually lovely, because what that's telling us then is that in these 3 digits, and we know there's at least 2 repeats, because there are not 11 different Sudoku digits, there are only 9, they can't all repeat, so exactly 2 repeat. But okay, let's ask the question, could those 2 be the repeating digits? Well, no, because A is going to have to go down here and B is going to have to go up there. And we've just got the paradox in smaller form again. So the only way you can repeat 2 digits in these 3 squares is if they are these 2 and they go up there. That is the only way it can possibly work. So that means we can go we can go A, B. Those must repeat. A is smaller than B by thermo, so that must be what's happening. We can't repeat this one as well, or as instead of, because we will create a paradox. And now, well, that's interesting as well, because now A and B are not 2. And that's because if one of these digits was a 2, what would we put in the bulb of the little thermometer? We'd have to put 1 in it, which we know doesn't go there. This is brilliant. This is absolutely brilliant. So A and B go down here. And it's all clear. It's all clear. If you can't see why it's clear, just pause the video. Give yourself a moment, because you will like it. Someone wrote, was it Rodri? Rodri Marsden, I think, wrote to recommend this puzzle and said it brought tears to his eyes. I totally understand that. I've got tears in my eyes. That is absolutely beautiful. Because where does this digit, I'll call it C, for those of you who managed to do it, by the way, congratulations. Where does C go in the world, in this column? Well, C's not in those 3 squares. Could you put C up here? No, because that's creating the paradox where A is greater than C and A is less than C. So C has to go there, which means C by Sudoku is that digit. So this digit is a 2. And that, unfortunately, well, it blows out of the water my idea that told me that that 2 was going to be in these 3 squares, but it's definitely progress, isn't it? I don't mind that it's blown that out of the water, because it's still remarkably beautiful. Well, and the other thing is, this thermo has basically got longer. Because, yeah, in effect, because this digit sits beneath A and B, you can view this now as the overall arrangement, that thermo and that thermo, as a 6-cell thermo, can't you? This used to be a 5-cell thermo, but now 2 we know 2 sits beneath A in the world of thermos, so this is effectively now yes. Now the other thing that's happened here, of course, is that this square now, yeah, this is absolutely beautiful. This has been set, frankly, by a genius. Blashyrkh, this is genius. It's ridiculously clever. Okay, so now I think I think I can now say that that is a 7, 8, 9 triple at in row 9, which is what I was hoping for. But to get your head around that, you have to sort of jump through a few logical hoops. Let me try and do that. So, first question is, where does 2 go in column 1? Now it's not here. We know it's not on the thermos because we can never put 1s in the bulb. So 2 is in those squares. Same exact logic must apply here. And that means that these 2 thermos here, these 2 cells, are now at least 3, which means these are at least 7. And that's obviously the same for this A thermo here. So now all of these thermos start with at least 3 and end with at least 7, which means that we can't have 6 in these squares anymore. These have to be a 7, 8, 9 triple. What's more, in order to accommodate, because one of these now will have to be a 5, won't it? Because we can't put 6 into any of these squares, because 6, 7, 8, 9, 10, that will break the world. So we know that these are at least 3, but they're a maximum of 5. So we can now say, I'm going to get rid of my A for a moment, these must be a 3, 4, 5 triple. The one that has 5 on it is going to go 5, 6, 7, 8, 9. The one that has 4 on it then, well, its second digit cannot be 6, can it? So it's going to have to be 5. So it will have to be a 4, 5, 6, 7, 8 thermo. And then the one that has 3 on it, whichever one of these is 3, will have to go 3, 4, 5, 6, 7. So these thermos now all step up by 1 each time they move. Which I'm sure might be interesting. We just have to figure out now. Do we know how are we going to know which? Is this going to be forced to be 3 because the 2 can? This is the only one of these. Yes. Oh gosh, yeah, it's all slotting together in my brain slowly. Yes, because remember, each of these thermos now, if we look at this thermo arrangement as a package over on the left hand side, we know that this digit to this digit we can view that as a 6-cell thermo. But this can't be 2 anymore. So this is at least 3. So 3, 4, 5, 4, 5, 6, 7, 8, in other words, is the absolute minimum that purple can be. So these 2 have to not have the ability to be 7. The only one that can be 7 is the one that has 2 here. 2, 3, 4, 3, 4, 3, 4, 5, 6, 7 is that's the only one that can work that way, because in this arrangement where we've constructed virtual 6-cell thermometers starting here and ending here, the only one that can have 2 on its smallest digit is this one. So this one has to be the one that stays the lowest, if you like, which means this is going to look like this. I hope that's clear. I mean, it's clear to me, and I have tried to explain that, I think, as well as I can. Now it's getting trickier though, because I don't know how on earth we're ever going to tell which order these are in. We know these are 3, 4. We know these are 4, 5. These are 5, 6. And then we know that digit is going to get transported down into these squares by our earlier logic. With, remember, the A's, B's and C's. Well, these are all the same shape, so that logic applies absolutely the same way here. So this is 5, 6, same as that. Then it goes 6, 7, 6, 7, 7, 8, 7, 8. This is 1, 8, 9 by Sudoku. This is 5, 6, 7 by Sudoku. Oh, I see. We're going to be able to get some of these digits, actually. That's 5, 6, 7 by Sudoku. This is 1, 8, 9 by Sudoku. That can't be 1. Right, but look now. We've got a 5, 6 pair here, so this is 7. We've got a 4, 5 pair here, so this is 6. So this is 6, this is 5. This is what's meant by this fills in magically, because it is sort of filling in magically. Look, that one somehow is a 5, 6 pair, so that's 7, that's 6, that's 5. And look, the order of the 5, 6, 7s just shifts slightly. It's weird. It's weird. Okay. That's a 1. It sees an 8, 9 pair at the end of the other thermos. That's not able to be 8, so that's 9, that's 8. It's not I don't actually understand how we're ever going to disambiguate the thermos, this thermo and this thermo. We'll give them colours. Then at least we can talk about them without feeling like we're being rude. Now, there's just not enough digits to disambiguate anything. Yes, I'm sorry. I realise I'm probably not making much sense, but I'm just anticipating how can I differentiate which one of these is 5 and which is 6. I obviously can't do it from the row, because the row, we can't put 5 or 6 in the row here to disambiguate these. So it implies I'm going to have to do it in some way from the columns. Oh, okay, maybe. Yes, I see. Yeah, I sort of am beginning to see this. If I label up this, or I'm not seeing how to do it, but I can believe it's possible to do it. If we just label these A, B, and C for a moment, then obviously, by the logic we did earlier, we know B and C have got to repeat on this thermo. So that's going to be B. Wow, where's my B? There. That's going to be C. Now A has to go down here, doesn't it? So A is up in the corner there. So this is now 3 or 4. So these squares are from 3, 4, 5, and 6 by Sudoku. Now that is not 5 or 6, so that's 3 or 4. I don't know if that means it has to be this one. I'm not certain about that. So 1 and 2 are now definitely in these squares. 1 and 2 are definitely in these squares by Sudoku. Ah, and that's not 1 or 2. Right, so we get a 1-2 pair in box 1 as a result of this absolute nonsense we're trying to deal with. Do we know one of those is a 5? Or is that not true? Because I could see that would allow me to get this as being a 5, and that would be hooray! Because of this 5. Oh no, I wouldn't. No, hang on, that's not true. Both of those can be 5. Oh, bobbins. No, I'm totally and utterly wrong. I'm sorry, I am totally misleading you. No, because I was looking at this and thinking I could put the 5 here, but I can't because that can also be 5, and I just didn't see it. Right, let me think about the bottom of column 1 then. We know that this is either 9, 8, 7, 6, 5. That's one option. 9, 8, 7. Yes, okay. So these digits are from 6, 7, 8 and 9, aren't they? Because this is either a 6, 7, 8 triple. If this is 4, we have to step up in units of 1. And I appreciate that. I hope that's clear why that is. It's clear to me. It's because It's because one of these bulbs is a 5. So once one of these is a 5, that thermo goes 5, 6, 7, 8, 9. And then the thermo that starts with 4 then, which has to increase, is going to have to take the lower digit at all times. So it's going to step up in units of 1 as well. Now, so this is either 6, 7, 8 or it's 7, 8, 9. But whatever it is, because it can't repeat there on the thermos, these digits will all be lower than these digits. They are going to go there. So this collection of digits is either 6, 7, 8 or 7, 8, 9. So we definitely know that 7 and 8 appear in these squares. And we definitely know that 7 and 8 therefore appear in those squares. Yeah, we've got 3 or a 4 here as well, haven't we? Because it's exactly the same structure to this sort of the column 1 position to the column 7 position. I've got something then. So that digit is restricted because that's seeing 1, 2, 3, 4, 5 in the row, and it's seeing 7 and 8 in the column, so that can only be 6 or 9, which makes a quadruple here, which means these squares can't be 6 now. So these are 3, 4, 5, but they're the same as those, aren't they? That's going to do it if that's right. These are 3, 4, 5. Yeah, I mean, it is. Look, because look, if we look at our labelling, A is going down here. B, is going down there. And C is going down there. So these are the same digits as these, and they can't involve 6. So that's a 5. There we go. So that's 5, 4, which means this is 5, 4, which means this is 3 in the corner. Yeah, that's 3 in the corner. That's 3 in the spotlight, losing its religion. Oh, that's magnificent. Now, right, so that's 4, and right, so this thermo has the opposite property. This thermo, everything here is bigger. 5, 6, 7, 8, 9. 6, 7, 8. 1, 2, 9 over there. These squares are 1, 2, 3 as a triple, so this is 1, this is 2, this is 3, that's 9, this is 2, this is 1. These don't have the ability to be 9 anymore, so we can tidy everything up here. That square becomes a 9 by Sudoku. These squares are a 6, 7, 8 triple. We know the 8 goes here. 8, 6, 7. That's 8, look. So we get a 1, 9 pair. That square is a something, 7 I think, by Sudoku. Right, these squares are 7, 8, 9. And we can nearly do some of that. 6 has got to go there. I think this is probably going to finish now. 7, 8, 9. 7, 8. Where's the 8, 9? So this is 1, this is 8, this is 9. Let's label these digits up. They're 1, 2, and 9. We can see which one's going to have to be the 9. 9, 1, 2. 1, 3, 4 over here. So 1 can only go there. This has got to be 3 or 4. Not sure we're doing this the most efficient way, but we're doing it a way that's going to probably allow us to do it. 2, 3, 8, and 9. Now, oh look, that's an 8, 9 pair, so we can just fill that in. This is a 2, 3 pair, and we can just fill that in. That does the 3 and the 4. That therefore forces this to be 5, 3, 4. That looks like it's a 5, that's a 4, that's a something, maybe a 6. This is a 2, 3 pair, that's doable. That gets us the 2 and the 1 and the 1 and the 9. I don't believe it. Yes. Some people have solved, 121 people have solved that in 2.7 days. And I suppose, is it a majority of them have rated that 2 stars? That is not 2 stars. I mean, that is it. Don't get me wrong. I mean, it's a work of sublime genius from a compositional perspective, and from every perspective. Blashyrkh, that is an absolutely beautiful Sudoku puzzle. And if that's the idea of the break-in, that you can't have 3 repeated digits in those 3 squares because you create paradoxes on the thermos, I applaud it to the heavens. But it's well, at least for me, it's not totally obvious that that's what I mean. I went through lots of other thoughts before I came up with that one. That was, I mean, I don't know. I sometimes worry that I'm going to look at the comments on days like this, and they're going to say, "Well, Simon, you missed the blinking obvious," and I may well have done. But what I'll tell you is that the way I did it, that is beautiful and brilliant. Oh my goodness me. I don't know if I've passed the geometry exam number 2. I think I'm going to go and ask the testers to check out geometry exam number 1 and whether we should be looking at that on the channel as well. Absolutely loved it. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.